Hello everyone, Toby solving Leetcode number 169, majority element. We are given an array, which is nums. It has a size, they call it n. You are not actually given it. It is just something that you'll have to get for yourself, basically. And the majority of the element always appears more than n divided by 2 times. And you may also assume that the majority element always exists in the array. So basically, you're given an array of numbers, or it could be strings too, but I think in this problem it's going to be numbers. And one of them always appears in the majority, which means that it's more than 50%. So that means you can do sort of tricks that I'll get into later. But to explain the problem a little further before I start walking you through the code, here are the examples. You're given 3, 2, and 3. Clearly that 3 is the majority element because it appears more than 50% of the time. Here, clearly it is 2 because there are 4 2s and 3 1s. So basically, the majority element appears more than n divided by 2 times. So it's going to be greater than. I guess I'll make this I. I is the individual number you're looping through. I appears more than n divided by 2 times. So what you're going to want to do is loop through it. If you don't want me to tell you the answer, you should leave now. I'm going to tell you the answer in terms of pseudocode by me saying it, and then I'm going to show you the code. And I'll give you a break between the two. But if you want to try to solve it yourself, now that I've kind of explained the problem, go try and solve it yourself. And then if you want to see my answer, which is pretty efficient, you can come back. Here is the solution in terms of pseudocode first. Basically, we need to loop through nums. Actually, I'll make this 1, 2, 2. We need to check every number in the array, and then if I greater than n or nums divided by 2, then you can just return it. And it's over. And that'll save you some time in the actual problem, which is good. But there is a trick to making this more efficient. You're going to want to use a hash map. And then in the hash map, you can save each number starting at 0 and then adding 1 for each time the number appears. And that's a matter of syntax in pretty much any language you're going to do. In Ruby, it's very straightforward. In Python, I've done it before, but it's a little bit more tricky. And then every time you have a new number, you want to add 1 and then check. Add 1 and then check. And that is basically it. That's the whole problem. It always appears. There's really no edge cases. So now that I've explained it, I'm going to show my code with the solution. If you want to code it yourself, I recommend leaving now, or just pausing the video and then coming back after you solve it. And you can compare your solution to my solution. And that's about it. So now that I've given you a chance to pause the video, here is, that's not my code. This is my code right here. I'm going to copy and paste it. It beats 35% and 17%. Not great, but also I think that's because I didn't use a lot of inbuilt functions. With Ruby on Leetcode, you kind of have to game it, where if you use more of the inbuilt functions, which are obviously more efficient, the more of them you use, the better your score is. The less of them you use, the less of your score is. Because they just happen to be a little bit more efficient for the same function. So I'm going to put this over here to give it the coloring, and then I'll explain it. But it's basically just what I said. It's a hash map being created with hash.new, with initializing everything as 0 initially. So that way we can add 1 to it. If we didn't put it in, like here, it would be nil as the initial value. And I'm pretty sure it wouldn't work. Yeah, it would not work, because you can't add 1 to nil. So let's try it again with that. Let's see the test pass. And they do. So I'm pretty sure it's working. Over here, nums.each, this is a for loop, a Python style for loop. And I is the individual number. It adds 1 to the hash for every number, which is, it's referencing by key. The key is the number. And then just if hash of I, which is the actual frequency of the number, is greater than nums.count divided by 2. So let's say it's 10 greater than 5. In that case, if its length is 10, or the count, then you have to be more than 5, so 6. And then that returns I, which is the individual number in the array. It would correspond to these. So I would be 2, and then it'd be 2, and then it'd be 1, and then it'd be 1, all the way through. I'm going to run that again. Don't know why I did, but yeah. Let's submit it, just make sure it works. And this appears to be pretty inefficient. And I explained why I think that is. This is the same thing. It got 35%. Sometimes the Leetcode gives bad execution for whatever reason. And that is about it. The memory is just doesn't even matter, because the lowest one is 211 and the highest is 213, and that is literally nothing in terms of the range. And yeah, that is about it for my solution. Now I'm going to do the big O notation for the thing, for the problem. Nums.each, this would be walking through every number you're given, so that'd be O of n. And then these individual functions would be O of 1, so they don't really count. And this would be O of 1, so that doesn't really count either. So I'm just going to delete some of this stuff first. O is O of n, and that is the big O notation for us, which is pretty efficient. Could be more efficient if we used, or if I used, the inbuilt Ruby functions, but I couldn't find one that worked for my use case. The follow-up right here is, can you solve the problem in linear time with O of 1 space? This is in linear time, but is not O of 1 space. If you have any solutions in O of 1 space, please put it below. That'd be great. I tried to solve it in O of 1 space, and it was getting kind of wonky. You actually can do it, but it won't be more efficient. I know how to do it, but it won't be as efficient in terms of runtime. The runtime will be worse, but the follow-up will be correct. And let's look at other people's solutions now. Let's see, Ruby. And the way you do that, I think this will work, but I haven't actually coded it out with the follow-up question, is that you can save one pair of numbers. Like, let's say for 2 and 1, you save 2 and 0, or 2 and 1, And then if any number shows up with frequency greater, and you can say like a temp number, then you replace it in the array. Actually, you can do it with O2 of space that way. Depends how they judge O of 1 space. I don't know all the rules. But there should be a way to do it where you save only one variable, and then you can check it against like a running total, and then if it's greater than the previous highest number, the total, then you get that one. And then I suppose you could just check that number against the count, and then that might work. That might be how I would say it in the interview if I had an interview with this problem. And then the interviewer might know how to like lead me in that direction or not. Let's look at some other people's solutions real quick before the video ends. See, a lot of people on this site, it says beats 100%. That's something the guy just typed. It doesn't mean anything. He just typed that. Because one time, me and my friends were doing Leetcode at the college, and we copied and pasted one in, and it wasn't really beat 100%. It was actually very inefficient. But they just say that it is. So this is definitely less readable than mine. A lot going on here. So it's basically my solution. Let's see if it actually beats 100%. Because it doesn't seem like it will. Hope I didn't delete something. I need these. Let's see if this actually beats it. It's not even correct. It doesn't even pass the test cases. So that guy's lying. See this guy? So this is a hash map. Returns nums 0 if nums 0. Okay, that's fine. You don't actually need this because my solution would solve that anyways. This is just my solution again. Let's see if it is really 80%. It's not. It's inefficient. So, see, people are lying. Or they just happen to get really good execution. And that's all I gotta say. That's the problem. Those were a couple of the solutions. Don't trust people on this page, the solutions page. They always lie. All the time. And, yeah, that's about it. Cheers, everybody.